Welcome to KMIT Vista. In this fourth unit in AI technologies and applications, we will be studying our fourth session topics, agriculture drones and agriculture robots. Today we will be seeing what is the difference between the drone and the robo and how to design a robo and a drone. So coming to the difference between the drone and the robo. So here we have a drone. We can see the drone in this robot. This is directly connected to the farm, whereas we have the drone. It is indirectly connected to the farm. So this is included in the farm, and this is in an air. So robot is a automated. Examples for robots are automated harvesting systems. It is a robot can be a weed control. Robot can be an autonomous system for navigating in the fields. Robots can be used for mowing, pruning, seeding, spraying and thinning. Robots is used in nurseries directly connected to the farm. Robots can be used as a row crop, vineyard, orchard applications, etc. Robots can also be used in sorting and packing applications. Robots can be used in agricultural farming. So coming to the agriculture drones works on a principle of precision agriculture. Always it concentrates about the total crop. It improves the yield of the crop, and it also be used for surveying the farmland. It is used in remote sensing mapping the fields, crops and lands. It also uses the multispectral measurements or site specific land developments. It is also used in analysis of soil health, vigor of the crops. It is drones are used for agriculture development, irrigation and nutrient management. Drones can also be used for fertilizers and pesticide measurements. Drones can be used which can create an environmental impact assessment and flood risk surveys. So these are the different we can see by pictorially the difference between the robot and a drone. So today we will discuss about how to create a single robot and a single drone. Okay, coming to the uses of the drones and robots. So always we know that robots and drones can integrate the GIS mapping. Second, it increases the yield of the crop. It saves the time and easy to use, and it can give return on investment. Coming to the different types of robots that we have, world first autonomous farm fleet robo. So where we have this type of robots, there we have a wheels, there is a plunger, there will be a antenna, there will be a different cameras, so on. Here also we have an agriculture robots for sustainable farming in future. These are the different robots we have already people are using in the fields. So coming to the robot. So what is the robo and how to create? Here we have a different blocks where we have wheels, 4 wheels, and we have a remote controlled rover. Rover is required, which is nothing but 4-wheeled rover. On this rover they are keeping a UR5 arm controller, where the arm controller start controlling the total mechanical equipment available in the rover. So here we have a one more fruit plucking robo. There we need a mechanical system which can pluck the fruit. So here we have a computer control, where based on the computer control we can operate the your robot. Here we have a mechanical device, and we have one more device called gripper. In this gripper, the gripper is designed with load cells. What is the use of load cells? Always the load cell measures the force or the weight that we have in the on a fruit. So second one is we need silicone fingers, and second one we need Raspberry Pi camera. This Raspberry Pi camera always pictures the image and give to an AI algorithm that is stored in the Justin Nano. Justin Nano is similar to the Raspberry Pi, which is a small microcontroller where it starts predicting the fruit or the fruit. So here we have a one more Oak D camera. Means to design a robot we need one controller, we need one detector which is written in a Python code, and microcontroller always we write the programs in C or C++ or Java. So this is the design of a robot. Coming to the drone. In the drone we have the frame. First is the frame, second one is propellers. 4 propellers are there. Second is it needs electronic speed control, and we have ultrasonic sensors. Next we need the lithium polymer batteries. We need the Raspberry Pi. Second one is Pix-Havoc flight controller. We need receiver, we need a mixture tanker, and we have a motor, and we have Raspberry Pi camera. Next we have a pump for nozzle, pump with nozzle, and we have a RC transmitter. Using RC transmitter we send a signal from remote to the drone, so that we can control the total system. So we have a motors. We have 4 motors. The 4 motors are responsible to rotate the fans, and we have a propellers which will be changing the direction of the drone, and we have pins and the system. We have a RC transmitter which can send the signal in one direction. Okay, we have the cameras to observe the why we use here we have a mixer tanker. So in the mixer tanker we can add a pesticide, so that this drone can be used as a spraying pesticide spraying drone for agriculture. So this is one more automatic pesticide sprayer. There we have a tank. In that tank we will fill the pesticide, so that we have the 4 fans to change the direction of the drone. So we have a microcontroller, we have a Raspberry Pi. Raspberry Pi always senses some images and process the images and predict something, so that it can start giving a condition to pluck the fruit or spray the farm. Okay. So coming to the application, how to design this robo or the sprayer. So first we will see how to build a robo. So building a machine learning agriculture robo is a multifaceted project that involves in combination of hardware plus software. So just now we saw we have a microcontroller who is controlling the total hardware, and we have a software which is detecting something or predicting something. So that software also uses some machine learning techniques. So to design all this, first we'll start with a problem. So what is the problem? Determine the specific agriculture task of your robo that will perform. A especially common tasks includes crop monitoring, weed detection and removal, harvesting. Second one is soil analysis. Coming to the research and planning, based on the data, based on the problem statement, we need to have a literature review, look on to the existing agriculture robots to understand the designs and the functionalities. This give you the insights, the what has to be done and improved. So next one is specifications. List out the specifications of your robot to include, so what should be the robot size, what should be the weight, what should be the lifetime of the battery lifetime, what are the types of sensors we need, what are the actuators are needed to design the robot, is the specifications that we want. The third thing we need is hardware components. In this hardware components, we have a microcontroller or the computer. Choose as a microcontroller. It can be Arduino based or Raspberry Pi based, which can create the brain of the robot. And we have sensors. Sensors are nothing but cameras, lidars, soil sensors and GPS monitors, modules or actuators. So coming to the sensors, the cameras are used to capture the images. It can be a RGB. Second is lidar. Lidar always measures the distance and use it for navigation. Second, soil sensors will be measuring the soil moisture, pH level and the temperature, and GPS module always detect the location or location tracking. It gives the latitude and longitude. Next one is the actuators. Motors, for the movement, we use DC motors or stepper motors. Robotic arms for doing the tasks like harvesting, building or purchase of the steady frame to hold all the components together. Second one, last one is power supply. It uses the batteries, rechargeable batteries or normal batteries. So next, coming to the software components required to design the agriculture robot. Operating systems are Raspberry Pi installed with Raspbian. Next is programming languages. Python is commonly used for ML and hardware interfacing, and C++ is used for real-time operations. Next is coming to the design of machine learning. So once we have selected the design of the robot, based on the implementation of robot, we need to collect the data, gather the data relevant to the tasks your robot will perform. This may include the images of the crop, weeds, images of the weeds and soil data, etc. So next is model training. So in a model training, if you have lot of images, we can choose image processing. Image recognition uses TensorFlow, PyChat and OpenCV for training the image and recognition. And based on the environmental data, we use regression models to predict the soil conditions or the crop health. Integrating the ML models with the robo control system. For instance, the model detects a weed, the robo should move to the location and remove it. Next is navigation and control. So when we want to design a navigation and control, these algorithms implement the path planning algorithms, implement the algorithms for efficient navigation in the field. Like we use A star, Dijkstra algorithms can be used for path finding. Control systems, develop a control system that can handle the robot movement and the task execution. It also uses PID controls to help and maintain the stable operation. Next is coming to the testing and iteration. Simulations before deploying. Once the system ML model is detecting or giving an accuracy of 100% or 90 best accuracy, always the output, the ML model is deployed in the field. Test your robot in the simulated environment to refine the algorithms. So, yield testing: conduct extensive field tests to ensure the robot performs well under real conditions, collect the feedback and iterate the design. So, once the model is ready, so we can deploy and maintain the model, so that always in deployment, once the model is tested, we can deploy in the agriculture setting, monitor its performance and make necessary adjustments. We can also maintain that regularly maintenance of the robot to ensure it remains operational. So, this is all about the designing the robo. Here in designing the robo, agriculture based robo, we need three things. One is the hardware, second one is the software, and we need the deployment systems. So, this is all about the agriculture robo.